Hi everyone. So today we'll be solving the lit code POTD, and that's its final prices with a special discount in a shop. So we are given an integer array price where price I is the price of the ith item in a shop. So basically we are given an array here and the prices of each of this item is the value of those particular prices I. Okay. So here if we take 0 in base indexing, so this is the second index, right? So second index price is 6, or the particular item is basically second, and this represent a this is ka price hai, like it's for rupees 6, as simple as that. So there is a special discount, and to get a discount, what are the two conditions? Pause the video and give a read to yourself at first. Try to understand directly, do not come to the solution. And so here it says that then you will receive a discount equivalent to prices j, where j is the minimum index. Okay, so first of all, to get a discount on each of this particular items, we have to fulfill two criteria. The first criteria is that if you want any discount on this following item, then the discount, like, it should have a less index value than rest of the others. This is the first, that is j should be less than I, sorry, more than I, or I should be less than j, right? So of course, zero base index in 0 is smaller than 1 2 3 4, right? That is the first criterion, that is fulfilling here for everything, all of the, this is very simple. And the next condition is that prices j should be more less than is equals to prices I. That is this, we are finding a discount on this 8 rupees 8 for just for now. Then this should have a more price than the next item, right? So, and then finally return after, if all this two of this not all, if two of this criteria conditions are fulfilled, then we will just minus with the index it is fulfilling. Therefore 8 minus 4 is what? 4. Because see, 8 is having less smaller index than first 4, and also because 8th index is 0 and 4th index is 1, and also 8 price is more than 4. Therefore 8 minus 4 and final discount will be 4. And finally we will return the integer array, that is answer. So here what we are doing for item 0 with price 0, what you will receive a discount equivalent to price is 1. Therefore, see, first 8 I have already explained you. Now let's go to the first index. So 4 is smaller, having smaller index than second side, right? But does 4, like 4 is greater than 6? No. So we will look for another index which have a more index value and have less price than 4, less or equals to price than 4. So 2 satisfies that, right? Therefore we will subtract 4 minus 2 and the final discount will be 2. Again, let's look for 6. Of course we will look for the forward elements. Therefore 2 definitely satisfied. Like 6 is greater than 2, is having less price than 6. Therefore 6 minus 2, 4. As simple as that. And then looking for, like, finding the discount for 2. Of course 3 satisfied the index condition, but is 2 greater than 3? No. Therefore 2 will not have any discount, and therefore 3 doesn't have any more elements left further. Therefore 3 will also not have any discount. The final answer array will be 4 2 4 2 3. And this is my solution that I've done, like I used a brute force, like I have taken 2 for loops, and definitely I is, from 0 to I plus plus, and j is from I plus 1 to prices dot size. Like, yeah, it will definitely, like, j should be, like, if you are checking on this, the next item j should be this, right? That is why I have written I plus 1, and this condition, that's what I'm using here, right? Because I have already used on condition here. So prices of j should be less than is equals to the prices of I. Less than or is equals to. Then only minus that. From prices I minus prices j, and then break. And then finally go again to the next element and store the final prices here. The return prices element. That is the final array. Okay. So yeah, this is the solution, and the time complexity for this solution is, of course, big of n squared because we are using two for loops here, right? And the space complexity for this is bigger of 1. No extra space we are using. We are just returning this prices again here, so no extra space is used, so this will have a big of constant space. And another solution, just do not solve like once you have your solution, yeah, this is the best feeling, but and after that, look for some other solution as well. Actually helps. The more number of solution we say in interview, the chances gets higher, right? The better solution we say and the number of approaches we say, more number of approaches we say in an interview, the selection rate gets higher, right? More. So I was just looking for the topics, then I saw okay, array stack and then monotonic stack, then I understood that it can be even solved using monotonic stack. If you do not know monotonic stack, then go to GFG and give a read to that about monotonic stack. Like this is the stack basically which we use to find the larger like great like large next larger element, next smaller element, like that. And it like help it follow the algorithm of like increasing elements, decreasing element. This is how it actually works. Give a read on GFG. And I have like I'll show you one of the code of monotonic stack, how that have been done. But this is a good solution. You can tell this to the interviewer, but also if you must tell it about this one as well. So I've taken a stack basically here, and then I am running on my for loop, and till the stack is not empty, this is my criteria that I have to look, right? So basically this is the solution for the monotonic stack approach. And I always try to run, like if I like see, like I have used ChatGPT here for a dry run approach so that I can show you. So basically in the monotonic approach, what they are showing is that, see, this is the array, right? So at first the I is equals to 0 and the stack was empty initially, right? So it cannot compare with anything. And then so we have pushed it. When nothing was there, so we have pushed it. We are taking the element. If it is fulfilling, then yeah, store it there, like prices, store it like that, like update the prices. But if not, then push that particular price. So that only happened, like we have pushed that 8 inside 0th index inside the stack. And again, when we have iterated the first element, then yeah, our condition have fulfilled. That is, price I is less than is equal to top element of the stack was what, 8. It is less than is equals to the top element of the stack, right? Therefore we have popped it, like popped 0, because it's already checked. So please get out of my stack. And that is how basically this is working. I hope I could make you understand. And again, push 1, and again the next element will come, the top element will be 1, like first index, and then it will basically it will be checking with the top element of the stack, and then if it's satisfied, then pop it out. If not, since here it did not satisfy, then we will push both. Right now there are 2 elements in the stack. Again here I is equals to 3, we have pushed 2 inside, so top element is 2, so it was checking with 2 here, right? So yeah, it did satisfy, so we will just pop 2 from the stack. That is how this is working, and I hope you could understand. And the time complexity here is basically big of n, because each index is pushed and popped from the stack at most once. And of course the space complexity here is more because you are using a stack, therefore the space complexity is there. But for the brute, the space is big of n, but yeah, it's having a better time complexity because each index is pushed and again it is also popped from the stack at most once. Like we are not doing, like we have just used a single for loop, right? And then we have not used the for loop j here. So this is also one of the better solution that you can just store it. Like there is a box for notes, right? You can just put it here. So yeah, I hope you understood the solution. It became a very long video, but yeah, this will be, I know this is a good video, helpful. And yeah, keep solving and keep grinding. Yeah, bye.